Friends, today I'm going to talk to you about angle alpha and angle kappa, which is sometimes confused, and I have given the explanation. Under the optics section, you will find this article. I will draw your attention to a chart that I created as a ready reckoner for you to understand what is angle alphas, angle kappas quickly. Now, angle kappa. Angle kappa is the difference between the visual axis and the pupillary axis, and this is measured at the pupillary plane. Angle alpha is the difference between the visual axis and optical axis, but this time it is measured at the nodal point of eye. So for both angle kappa and angle alpha, the common thing is the visual axis, right? So let us now look into what does this visual axis mean. A visual axis is a line that comes from the fixation target over here. In this case, it's the bird. The line that goes from the fixation target to the first nodal point of the eye, and then the line that emerges from the second nodal point of the eye to the fovea. So this line actually is the visual axis of the eye. Now, the difference between the visual axis and the pupillary axis, that is a line that goes through the center of the pupil, is angle kappa measured at the pupillary plane. Angle alpha again is the visual axis, which is common for both angle kappa and angle alpha. Angle alpha is the difference between the visual axis and the optical axis of the eye, right? Optical axis of the eye, which is measured at the nodal point of the eye. Now let me explain you what we mean by the optical axis of the eye. And here in this diagram, I've given an understanding about the optical axis of the eye. Now, sometimes many say that the optical axis of the eye is actually the limbus center, which is actually very loosely said. I mean, that may not be always a correct statement to say. But optical axis of the eye, you could say as a line that intersects the corneal plane, right? That's basically the optical axis of the eye. So the optical axis of the eye will be the line that is perpendicular to the plane of the cornea and intersects the center of the pupil. So that's basically the optical axis of the eye. This line that intersects the plane of the cornea, which is perpendicularly intersecting the plane of the cornea and going through the center of the pupil, the optical axis of the eye. And this optical axis and visual axis difference is called the angle alpha. Now, also you will find angle sometimes it's not very common, angle lambda, which is basically the difference between pupillary axis and the line of sight. Like angle kappa, pupillary axis is involved. Angle lambda also pupillary axis is involved. But this time it is a difference between not the visual axis and pupillary axis, but the pupillary axis and the line of sight. And again, it is also measured at the pupillary plane, like angle kappa. So what is line of sight? Line of sight is again a line that goes from the fixation target to the center of the pupil. Remember, visual axis is the line from the fixation target to the nodal point of the eye, and from the nodal point of the eye to the fovea. But line of sight is from the fixation target to the center of the pupil. That's basically your line of sight, and the difference between the line of sight and the pupillary axis is the angle lambda. Now, in the biometric machine, you will find this terminology is chord mu. What is chord mu or CW chord? Chord mu is the equivalent of angle kappa. Now, however, there's a small difference. In angle kappa, you're measuring an angle, but in chord mu, it is equivalent to angle kappa, but you are not measuring an angle here. You're measuring distances, right? So chord distances. And you will find in the lens stud the difference between the x and y coordinates. So that distance is measured, which is somewhat similar to angle kappa, but technically it would not be correct to say that it measures an angle. It's basically the difference between the x and y coordinates that you find in the lens stud or in the Allmaster. In the Allmaster, you however get the chord mu directly computed. So what does that mean actually? It is the difference between the apparent pupil center and the Purkinje's first reflex on the cornea, right? If you shine a torch, you get a reflex from the cornea. That's basically a Purkinje's reflex. So the chord mu is the difference between the apparent pupil center and the Purkinje's reflex, or P1. Now notice I'm saying apparent pupil center. Why am I saying apparent pupil center? Because this biometric machines always measure this, though they're measuring the difference between visual axis and the pupil center, they're actually measuring on the corneal plane, not on the pupillary plane. They're measuring on the corneal plane. And if you're measuring something on the corneal plane that you're supposed to measure on the pupillary plane, you will always have an element of magnification, because cornea is a convex lens, right? Its total power is convex. So you're measuring this difference at the corneal plane, so it is kind of apparent and not maybe absolutely real, right? So that's the difference between chord mu that is measured on the corneal plane by the biometric machines, and chord mu sometimes measured on the real or actual basis, like in the pentagram. Now, chord alpha, what is chord alpha? Like chord mu, which is kind of the difference between the pupil center and the visual axis, which is kind of the light reflex of the Purkinje's reflex that is taken as very close to the visual axis. So chord mu is equivalent to angle kappa. Chord alpha is actually equivalent to angle alpha, right? And that is measured by the coaxially sighted light reflex, which is the Purkinje's reflex 1, that is uh, the light that shines from the cornea to the limbus center or the optical center of the eye. As I said before, optical center is sometimes loosely said as the limbus center. So this machines that gives you a value often gives you the chord alpha as a difference between the Purkinje's reflex from the cornea and the limbus center, right? So that they give you as a chord alpha. So I hope you will find this really interesting, and this you will find under the optics section in this article. If you go into the optics section and then go into this article, you will find this chart over here. Alternatively, you can always use the search button and type angle kappa, angle alpha, right? I hope you find this helpful and interesting. Keep following my channel and subscribe. Don't forget to subscribe to get regular updates.